everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, thank you. How's your weekend? Good? Yeah? Good rest? How's home play over the weekend? Tell your neighbor what the home play was. Let's go. Supposed to have an excellent weekend? Let's go. Some of you are like, what? You didn't do the home play? All right. All right. Anyways, warm-up 78 is on the screen. Let's get started, please. Today we're adding a couple more things to this portion of the session with quadratics, giving you some review. Hopefully all this should be able to do all these. Anyways, I'll give you some time. Copy and go. All right, we good? Yes, Mr. Q. All right. So, being that it's Monday, I'm going to go over this. And at this time, you don't need any Chromebooks in front of you. Put those away, please. Appreciate it. Thank you. Now, this is being recorded, and just to make sure everybody knows where we're at, next Monday, report cards are going out from the district. Everybody with me? Yeah? So everybody, I'm pretty sure, is caught up with their grades and fine and dandy. Am I right or am I right? All right, good. Just double checking. As I was telling my seniors earlier, it's like this month's going to go super fast. January took like forever, like almost a year or something, right? But February, guys, it's going to go like that. So stay focused, please. Make sure you're getting all your work done. Wait a minute. Beginning of the month, Geo. Let's go. But we'll do that tomorrow just to save time. Because I need all the time in the world for today's session. Here we go. First things first, it needs to be in standard form equal to what? 0. So we got 3x squared plus 27 equals to 0. Looking at it, we have a binomial. What's the easiest way of solving this quadratic? Using square roots. So what do? I need to leave x by itself. Minus 27 minus 27. We get 3x squared equals negative 27. What's my next step, everyone? Divide by 3, divide by 3. X squared equals negative 9. And what is my last step? If we're solving with square roots, we'll square root and square root. That gives us x equals plus minus. Tell your neighbor the answer of this. What is the answer of that? Of course, Dana's got this. But everybody, it's what? 3i. That is correct. And that was last Friday's pop party on imaginary numbers, right? Let's go, Cesar. Oh, yeah, we got this. Number 2 says, graph without a table, and then write the rule and do the transformation. Let me do number 2. For number 2, by now you guys should have been able to do that one by yourself, but here it goes one more time. All right, because who's going to help me out with this one? So to graph f of x equals x squared, I start at negative 2, and that gives me 4. 1, 2, 3, 4. Negative 1 gives me 0, 1, and 2. All right. Now, by now, you guys are doing this automatic in your noodle, right? And in your paper. So this is f of x. All right, so now we need to substitute values in here. So a is 1, b is 1, h is 3, and k is negative 4. So my new transformation, g of x equals 1 times f, 1 over 1x minus 3 to the second power minus 4. What did we say last week? That we no longer use the 1's or the f, so I'm going to write g of x equals x minus 3 squared minus 4. Therefore, where am I moving all these points? Tell your neighbor, where am I moving all those points? Where am I moving all these points? I look like Mario's got this one. Mario, where am I moving it? Three to the right. And 4 down. All right. 3 to the right. 4 down. 1, 2, 3, 4. And that is our g of x. Hands if you got something like that by yourself. Yeah, okay. Let's go to number 3. Number 3 says solve by completing the square. Once again, I'm giving you guys plenty of practice with completing the square because tomorrow, actually, let's go. The next portion is coming up. There it goes. What is the first step, Enrique, before you leave? First step. To 0, x squared minus 8x minus 10 equal to 0. All right, since you haven't left, what is the next step? Divided by 1, so that gives us x squared minus 8x minus 10 equal to 0. Hands if you agree so far? Yeah? From there we need to eliminate the constant. So what do? Add 10, x squared minus 8x equals to 10. I need to complete the square. How do I complete the square? Negative 8 over 2 squared to both sides. Negative 8 over 2 squared to both sides. We end up with x squared minus 8x plus 16 equals to 10 plus 16. So far so good, yes? However, we need to simplify the right side. That is 26. So we end up with x squared minus 8x plus 16. Yes? All right, next, factor. Square root of the first. Square root of the last. Sine of the middle equals to that. Or in other words, x minus 4 squared equals to 26. All right, last. How do I cancel this, everyone? Square root, x minus 4 equals plus minus square root of 26. And last but not least, plus 4, x equals 4 plus minus square root of 26. So how many equations can I get from here? 2. 4 plus square root of 26 and 4 minus square root of 26. All right. How are we doing? Pretty good, yeah? All right. I was just talking about that. I bumped into a student that works at In-N-Out. They're like, Mr. Q, do you still do that to the fridge? Yeah, of course. Anyways, last one. Example 4 says compute the voltage. And I think Gio's got this one. Right. However, being that it's Monday, I'm going to go over it, yeah? So my formula is V equals I times Z. Is that correct? Yes? All right. However, I need the impedance, the Z, because they just want us to find the voltage for the what? Capacitor. So, say, neighbor, how much would be the impedance for the capacitor, which is the capacitor? What would be the impedance? All right. Let's see. How about Edwin? What would be the capacitor? Here are my capacitors, these two right here. Oh, let me label it for those of you that need to label first. Capacitor. This is resistor, and inductor. So what would be my impedance? That is correct, negative 6I. Times. What is our I, everyone? Our I is 24 plus 12I. And that's going to give us the voltage of the current going through the capacitor. So distribute. So that is 6 times 24, that's 144, negative 144i. And then 12i times negative 6, that's negative 672i squared. However, what do we know about the I squared, everyone? Times negative 1. Is that correct? So negative 72 times negative 1, that's positive 72. And then we write this at the end, negative 144i. And this is the voltage going through the capacitors. All right, we good? All right. So with that said, copy the agenda, please. Warm-up number 78 is done. Complex numbers. And tonight you have a play sheet, numbers 1 through 12, in regards to complex numbers. Other than that, anything exciting over the weekend? No? Just chill? It was a chill weekend, yeah? I went to cut my hair this time. I didn't cut it myself. Because I was trying to grow this longer and get like a faux hawk underneath here. However, with time, the back was growing a little bit over too much. So I had, you know what? I need to make the trip this weekend and do that. All right. So warm-up 78 is done. Complex numbers, real numbers, and non-real numbers on the play sheets. Here's the code access to that, JSV59, JSV59. And once again, this is being recorded. Just a reminder, tell your neighbor when our progress report's going out for all your classes. Remind your neighbor, please. Yes, Monday. All right, so get a Cornell note ready, please. And it reads, I can identify complex solutions to quadratic equations. I can identify complex solutions to quadratic equations. I can identify complex solutions to quadratic equations. Now, we're in the middle of complex numbers, and you guys have been working with that since last week. We applied that to electronics because I told you that's one of my areas of expertise, and I love electronics. That's what I used to do, so that you guys can see the complex numbers at work. So, complex solutions. What does that look like? All right. Before we move forward, complex numbers. Remind your neighbor what is a complex number. Remind your neighbor what is a complex number. Without looking at your notes, by now you should know what they are. All right, looks like Enrique's got this. I see you, Enrique. Caitlin, of course, got this. But let's go with Joseph. What are complex numbers? It's a number with a what? Imaginary and a real number. That is correct. A number that contains a real number and an imaginary number. We've been looking at those already, working with those. So write this down on your notes, please. Identify real solutions in a quadratic equation. Write that down, please. Identify real solutions in a quadratic equation. Identify real solutions in a quadratic equation. So tonight's home play, they're going to ask you for either a real solution or a non-real solution. So what does that mean, Mr. Q? Well, let's clear that up. That's why I wanted to write this down. So on this side, I'm going to write real solutions. Do that in blue if you have blue. On the right side, you're going to write non-real solutions. Non-real solutions. So, we've been solving quadratic equations, and here go what real solutions look like. Ready? Write this down. X equals, and then at the end we get either a plus, minus, give me a number. 4. Okay. So, is that a real number? Yes. All right. Either a positive or a negative 4. Okay, that's one. Let's label that A. Let's go to B. How about X equals 5 plus minus 3? Yeah, that's also real. Why? Because we can have two equations, right? Turn to your neighbor, let them know the two equations that we get from here. What are my two equations? Two equations. All right. What are my two equations, Geo? X sub 1 is what? 8, which is 5 plus 3. And X sub 2 is what? 2, which is 5 minus 3. Okay. Hands, have you got that? Yes? All right. C. How about X equals 5 plus minus square root of 26? That's also real, but notice that we have a little dilemma here because this becomes a decimal, right? But to be exact, I'm going to label this is exact. When we leave it in the square root form, it's an exact answer. Okay. So all those you've seen before, yes? All right. Today and last week, toward the end, we saw stuff that looked like this. X equals plus minus square root of negative 9. So turn to your neighbor, let them know what X sub 1 is and what X sub 2 is for that one. What is X sub 1 and X sub 2? Gio, pass them one. Mario, let's go, Mario. Square root of negative 9 is 3. 3i. So it's a positive 3i, or the second one is negative 3i. Hands, have you got that? Yeah, we've been looking at negative numbers. Let's do another one. X equals 5 plus minus square root of negative 16. 5 plus minus square root of negative 16. So, X sub 1, X sub 2. Tell your neighbor what X sub 1 is and what X sub 2 is from there. What is X sub 1 and X sub 2? All right. Good conversation. Mario, pass someone. Enrique, what is X sub 1? All right. Help them out. How about Caitlin? 5 minus. What is square root of negative 16? 4i. So that's X sub 1. So what would be X sub 2? From the corner. Hands, have you got that? All right. So check this out. Now, for those of you that you're like, Mr. Q, it's because it's Monday, okay? And then tomorrow's going to be Tuesday. Look up. Look at these and look at these. What made these imaginary numbers and not these? Talk it over your neighbor. What made these, once again, imaginary numbers? What made those imaginary numbers? All right, looks like Monse in the back's got this. I see you, Monse. Well, let's go with Elijah. what makes these non-real solutions? What makes them? Square root of what? Of a negative number. Make a note right here on the side. Bam. That in parentheses. Whenever you have a negative square root, that's when we have non-real solutions, also known as, label this again, imaginary. Imaginary. All right? So, now that you see we have reals, non-reals, so let's get into some of these examples. So, on your paper, I want you to create a coordinate plane from negative 10 to 10 on the domain and range, and then write this problem on the side, and it reads, graph and state how many real solutions. And we got y equals 2x squared plus 4x plus 1. I'll give you guys some time for that. Set it up. Make sure your scaling is as neat as possible. So, it says, graph and state how many real solutions. So first things first, let's set this equal to, everyone, 0. So 0 equals 2x squared plus 4x plus 1. All right? So today I'm going to show you a strategy that you're going to apply tonight for your home plate. Here it goes. And what it is that we're going to get rid of the constant right now. Look up. Get rid of the constant, so minus 1, minus 1. We end up with negative 1 equals 2x squared plus 4x. Are we following so far? Yes? All right, so this is what I want you to do tonight. Whenever they give you something like this, asking you how many solutions, we're going to make it into a system. Here it goes. On the side, let's do a system like this. And it's got two equations. One of them is in black. The other one is in green. So the one in black, I'm going to label f of x. F of x equals 2x squared plus 4x. The other one in green, since we already have an f of x, that means this is our g of x. G of x equals negative 1. All right. So let's graph the easy one. How do you graph g of x equals negative 1 or y equals negative 1? Well, we go to negative 1. Here it is. And then you sketch a straight line going through that point. Do that yourself, please, and use a different color if you can. There it is. However, for f of x, if I ask you to graph f of x, what would you do to graph f of x? Tell your neighbor, what would you do to graph f of x? Who went last? Enrique? Enrique, what would you, or, oh, Caitlin. Pass someone, Caitlin. Joseph, what would you do to graph f of x? Okay. How about we make a table? So, x, f of x, and what value shall we use? All right. So, let's substitute those in here. So we got 2 parentheses squared plus 4 parentheses. All right. So, first value is negative 2. Let me zoom in. So this is 4, sorry, give me a second. This is 2 times, what is 2 squared? 4 plus, what is 4 times negative 2? That's negative 8. Okay, so what is 2 times 4? 8 plus negative 8, and that gives us 0. Let's do it again. 2 parentheses squared plus 4 parentheses. And my next value is negative 1. Negative 1. So 2 times, what is negative 1 squared? 1. Plus 4 times negative 1 is negative 4. So 2 times 1 is 2 plus negative 4, and that gives us negative 2. Next, 2 parentheses squared plus 4 parentheses, and now we're going to substitute 0. So what is 2 times 0 squared? 0. What is 4 times 0? 0. So this is 0. Next, 2 parentheses squared plus 4 parentheses. My next value is 1. So, let me scoot up. We end up with 2 times 1 plus 4 times 1. So this is 2 plus 4, and that gives me 6. All right, find that last number. Tell your neighbor what you got for the last number. Last number. All right. Looks like Mario's got the last number. But who went last? Who went last? Joseph, pass him one. Mario, what did you get for the last number? 8 plus 8 is 16. Hands if you got 16. All right, good. All right. So let's graph those. Let me zoom out. Here we go. Negative 2, 0. Negative 2, 0. It's right there. Negative 1, negative 2. Negative 1, negative 2. 0, 0. 1, 6. And 2, 16. 2, 16 is somewhere up. See, 1, 2, 3, 4, 5, 6. Yeah, somewhere up here. All right, let's graph that. Bless you. All right. And this is f of x, and this was g of x. So look up, please. This one says graph and state how many real solutions. So look what I'm going to write. For this one that we just did, we're going to write, I'm going to put an asterisk here. 2 real solutions. 2 real solutions. All right. Next, I want you to write this one down. Let's write, where do I write it? Let me write it over here. Y equals 2x squared plus 4x plus 2. So, let's say I gave you this one instead. What is the first thing we do? Everyone, set it equal to 0. And then, what do I do next? One last, Mario? Mario, what do I do next? Yeah. Minus 2, minus 2. So we end up with negative 2 equals 2x squared plus 4x. All right. From there, Gio, pass the one. Joseph, what do I do from there? Yeah, write the 2x as f of x, 2x squared plus 4x, and then the other one as g of x equals negative 2. All right, so let's graph G of x equals -2. -2 is right here. Graph your red line going through that point. And look up please. F of x, isn't it the same as this one? Yeah, so I don't need to do the table and it's already graphed for me. So by looking at this, I'm going to write for this one, look up. 1 solution. Or 1 real solution. You're like, All right. Some of you already caught on. Some of you haven't. Look up. This is f of x. This is g of x. Look at the black graph. Look at the red graph. That only has 1 real solution. Look at the previous one. Look at the black graph. Look at the green graph. That one has 2 real solutions. Talk it over your neighbor, see if they see it. Tell your neighbor what you see. All right. What do you see? Let's go with, what do you see? Caesar. What do you see, Caesar? Anything? Did everybody hear that? That is correct. Say it a little bit louder. Did everybody hear that? Very good. He said, for the 1 real solution, f of x only touches the red one once. So that means for this one, f of x touches g of x how many times? 2 times. That is true. So, over here on the side, I want you to write this. Y equals 2x squared plus 4x plus 3. All right, make this into a system, please, and then graph it. All right, looks like Enrique's got it. Very good, Enrique. All right, what'd you get for f of x, Sebastian? And for g of x? -3. Okay, hands, have you got that? All right, that is correct. You set it equal to 0, subtract 3 from each side, and that's how you get. So let's graph g of x equals -3. Here it is. That's our new g of x. F of x is right here. Look at the black graph and look at the blue graph and tell your neighbor how many real solutions for that system. Talk to your neighbor. Tell them how many real solutions for that. How many real solutions? Sebastian, pass someone. Gabriel, how many real solutions for that system? 0 real solutions. Hands if you agree with that. Tell your neighbor why, please. Let them know why. Why 0 solutions for that one? Let's see. Let's go with Franco. Why no solutions for that one? No real solutions. It doesn't intersect. Yeah, that is correct. So, there you go. Tonight, hopefully, you're going to have some of these, so make sure you make your quadratic into a system. graph both, and that's how many times it's going to tell you the solutions. All right? So from 1 to 5, I'll provide you with those. 5 fours, 5 fours. Okay. So we got this, we got this. Copy this one. Example 2b. State the number of real solutions without graphing. Without graphing. State the number of real solutions without graphing, and they give us y equals 2x squared plus 4x plus 2 without graphing. All right, so on the right side, I'm going to write the steps. Step number 1, SF. Tell you never what that means. All right, what does that mean, Julissa? Standard form equal to 0. That is correct. So 0 equals 2x squared plus 4x plus 2. Step 2, ID, A, B, and C. ID, A, B, and C. All right, so to identify A, B, and C, you guys remember this, yes? Remind your neighbor what to do to identify A, B, and C. What do we do to identify A, B, and C? Are you guys tired or, yeah, being on Monday? Come on, my goodness. It's only algebra 2. So we write the standard form underneath here. We got ax squared plus bx plus c equal to 0. And that's how we identify A, B, and C. So what is A, everyone? A is 2. B is 4, and C is 2. All right. Step 3. This is it's going to be something new for us this year, but you've seen it before. I want you to write discriminant. Discriminant. Let me rewrite that so you guys can see the discriminant. Discriminant. And where do I get that from, Mr. Q? You get it from the QF. That by now we know it by memory, and probably Gio's going to enlighten us with that. QF. Remind your neighbor what the QF is without looking at your notes. What is QF? X equals minus B plus minus square root. And look what I'm going to use in red. B squared minus 4AC over 2A. So this part, guys, this is what we call the discriminant. Discriminant. So we're going to use that. All right? So, with that said, if I use this part, B squared minus 4AC, we write parentheses squared equals, not equals, minus, minus 4 parentheses parentheses. All right, what is B? B is 4. What is A? A is 2. And what is C is 2. Did everybody see it? Yes? All right, so 4 squared is 16. Negative 4 times 2 times 2, that's negative 16. 16 minus 16 is 0. So with this, I can tell you there is one real solution. How do you know, Mr. Q? Well, let me give you a little cheat sheet over here. Write this down. Write number. And then you're going to write real solutions. So, whenever you end up at the end, once you use the discriminant with a positive number, you get two real solutions. That whenever you end up with a positive number, you get two real solutions. You get that? If you end up with a negative number, you get zero real solutions. So look up really quick. These are the options. At the end, you can simplify, get a positive number. How many solutions will you have if it's a positive number? 2. If you end up with a number here that's a negative, you get zero real solutions. So what are the other options? Positive or negative, or zero. If you end up with 0, you will get one real solution. Those are the only options. Now, why? Look up. Why is it that if I end up with a negative, there are no real solutions? Well, question. Where did all this come from? From inside of what? Inside of what? Square roots. Is that correct? So if I simplify the square root and at the end I get a negative number, what is this? Imaginary. That is correct. Did everybody see it? Kind of, sort of. All right. From 1 to 5, how comfortable are you with this? All right. For home plate, you're going to have plenty of these to practice. You need to set it in standard form, identify A, B, and C, and then you get your discriminant and solve. All right? Do we have time for one more? Jesus, what do you think? All right, let's stop right there. Jesus says no. All right, so make sure you do your home play. Yes? Did everybody get the code? Let's see. Yes. Because I'm always cool. What's that? Well, what? I wasn't. Let's go. I go. Let's go. And I was like, how come there's a game on Monday? You know what I'm saying? That's good, though. All right, let's do it. Anyways, there's the code, guys. Make sure you get that practice in. I'll stop the video right here. Those of you following on YouTube, make sure you submit your work and get some practice in. See you guys next time. Peace.